That's the potential relay. Here's your coil on the potential relay. Notice the size of the wire on the coil, much smaller. It's not measuring a lot of current, it's measuring voltage. Okay? What it does is move that set of contacts and opens them up when the voltage gets right. Okay? Now, the hot wire relay is almost a mystery to us. Now, it is a very complicated device to troubleshoot, whereas the other two relays are very easy to troubleshoot. Okay, I didn't say this, but we can measure the coil, the resistance of the coil to see if it's good. We can measure the contacts on a current relay to see if they're open when they're de-energized. In fact, if you have this loose, you can turn it upside down and see if the contacts mate, because it's gravity that keeps them down. Okay, that's one way you can troubleshoot that one. The potential relay 1, 2, and 5. 5 and 2 connect your coil, so you could actually measure the resistance of the coil between 2 and 5, and the contact should be closed, so between 1 and 2 should be zero resistance. All right. The hot wire relay. It is a heat motor. Now that's kind of a strange way to say something, but it has a thermal disc inside of it, a bimetal strip. Okay. As this bimetal strip heats up, it moves a set of contacts. Okay. Many of them have more than one contact connected that may actually act as an overload device too. Okay. It may be that this is going to your start windings, and this one would be going to your main current coming through. It depends on the device. But it's very possible that it would de-energize the start winding, but if it still continues to pull too much current as this heats up, also open the other set of contacts to the overload. They are hard to troubleshoot with meters. Okay, you don't see that many of them out there. Where you do see them, at least I have, is in a lot of the research equipment that has explosion-proof boxes or cabinets. You don't want any sparks inside of it, so these devices are mounted external to the cabinet. That makes sense? Mm-hmm. Okay. If you see one and you want to look at it a little closer, there's the inside of one, there's the box. All right. Electronics have changed the way we do a lot of things, and a lot of the starting relays nowadays are solid state. A solid state capacitor and relay combined is right here. There's your capacitor part. Inside you do have the overload, but you also have something like the thermistor. The thermistor, the hotter it gets, the less current it will allow us to go through it. These are sized for certain size motors. That's the way they work. It limits the amount of current that would be going to the start winding as it heats up. Okay. It's not magic, but it's hard to see it because we don't have anything mechanical in there that moves. Y'all see what I'm saying there? Got to have a little imagination when it comes to that kind of stuff. All right. Magnetic starters. Now, you see more magnetic starters in the industrial and commercial than you do in the residential, but I don't want to leave them out, and the reason being because it does not have to be a three-phase motor to have a magnetic starter. You can have a magnetic starter on a single-phase motor. It's just a means of protecting and starting the motor. Okay? A magnetic starter, and I'm going to try to draw this one right quick. I'm going to draw a 3-pole magnetic starter. would have L1, L2, and L3 lights open. This would go to my motor, three-phase motor. We have T1, T2, T3 going to the motor. Okay? We have a coil. Okay? I left something out. All I've got right now is a contactor. Kind of purposely done that because a magnetic starter is a combination of a contactor and overload protection. It's two things built into one. Okay. In that magnetic starter or motor starter, that term's interchangeable, we're going to have, and y'all excuse my drawing here, we're going to have the overload devices. Okay? This is measuring the amount of current that's going to that motor when it's operating. On each one of those devices, y'all remember the remote overload?
Mm-hmm.
Okay. This is what we got. Sometimes they'll have all these connected to one switch. Sometimes they'll have individual switches for each leg. We're going to show one. Okay. I'm going to move that over to here so that it'll make it a little bit better to see. That is my overload switch on my contact or my motor starter. It's going to be connected to the coil C. These are C contacts. Okay. Now this is going to be going to my controls. Okay. This may actually use the power off of the contactor itself or the motor starter itself, or it may use a different control voltage. It doesn't matter. When this is energized, it's going to close these contacts. If I have the current on one of these legs to exceed what the rating is, then it's going to open this switch. If I open this switch, what's going to happen to these?
They'll close.
They're going to all open, I hope. Okay. If I exceed the current, it opens this normally closed contact, de-energizes this coil, which in turn opens the contacts. Y'all see something here that's important with three-phase. If I were only to open one or two contacts, one in particular, I now have a single phasing condition. So I've got to open all three. I've got to stop the entire current from going to that device. Okay? You could have a situation where only two of them open up and the motor can still run. Okay. Not very well, but it still runs.
Catch your finger.
Mm-hmm.
They can catch your finger.
Well, that plus it would actually not be protected. It's going to overheat. It's going to overheat. And if this device is not doing its job, then I've got a problem. But that's the reason you have a motor starter. These heaters, as they're called, have to be rated for the motor. Okay. When you look at the motor starter, this is one complete. It's a lot to it. We broke it down to where you have the case and the contacts. This is part of the contacts. This is what the motor current goes through. This is the coil that pulls the plunger down, or armatures it should be called. Okay. This is the overload part of it. Okay. Notice the manual reset. This is the thermal, in this particular case, thermal overload. There is a solder pot in here that the heater, that's the heater, I don't know if you can see that or not, but that's the heater where the main current or the motor current would be going through. If this exceeds its limit, it melts that solder, which allows this to ratchet and open the switch that is in series with the coil. In turn, all of the contactors open, the motor stops. All right. Now, I promise you we have covered several different components here, but this is only a few of all the components that you're gonna see out there, and I mean just a few.
So,
Okay. As you go through the lessons, you're gonna find that you're gonna see these again, and again, and again, and again. And we're gonna expand upon some description and operation of them, but we're gonna add some more in there to you, too. There's another section that's coming up a little later that's gonna cover pressure switches, limit devices. I can't even think of all of it, and I'm just kind of like, poof, okay. Any questions? Okay, I'm going to let that conclude this part. Remember that this is not the lab. You've got a good sized lab to do, and be honest with you, you don't need to do this with a large group. You need to break down into some small groups to do this. Otherwise, you're going to be sitting back watching somebody else do it. You're not going to learn that way. Okay? So, but you need to do this one 2 or 3 at a time.